you've walked through what is intelligence, what is thinking, and what is AI. And we finally get to this very provocative and, in my humble opinion, a very beautiful question. How do you think with machines? So, Kez, this is something that I know you're headed in a very different direction, but I think there's some folks that might look at this and go, how do you think with machines? Well, isn't that just prompt engineering?
Look, there are a lot of people out there who are going at it that way, right? So this idea, prompting is the new programming and thinking about it, but that's using the idea of what I call thinking next to a machine. And this is the concept, which is, what I'm trying to shake up a little bit. So trying to use a different mental model, to be able to this idea of what does it mean to augment intelligence? What does it mean to think with machines? It's beyond prompting. It's beyond like automating or just using generative AI to create, beautiful pictures. There's so much more to it. And this is what I'm trying to bring together in what I call thinking in systems.
So let's dive into that because this is honestly one of my favorite ideas that you've come up with. You and I have been working together for nearly 15 years now. We're very good friends. And, we're both fans of standing on the shoulders of giants to see farther. And that's exactly what you did. And to me, it's mind boggling how long you sat with a concept that you actually codified in words and you've really developed and fleshed out over the course of this year, because it was back on January 8th of 2024 that in your second Centaurian Substack article, you actually came up with this notion of thinking in systems and thinking with systems. And you started with Nobel laureate Daniel Kahneman. What better giant to stand atop his shoulders? So help us start understanding what you've gotten to and where you started with Danny Kahneman and, of course, the late Amos Tversky's work around thinking fast and slow in System 1 and System 2.
Look, I've been enamored with the work of Danny Kahneman and Amos Tversky, and it was groundbreaking in his research, and it took a long time for people to really embrace it. And I love the fact that, Danny Kahneman, finally got around to writing everything into a popular book, which everyone can read. And he brought this mental model of System 1 and System 2, which really encapsulated a lot of the research, I'd been doing. One of the biggest breakthroughs as I looked at the neuroscience of motivation was understanding, what is it that we've chunked through history? What is actually already embedded in our brains? And this is a lot to do with System 1. System 1 is our old evolutionary brain. And it can, not only do things which have been, basically embedded in our brains through genetics, which, take us back millions of years, allow us to be able to find the perfect landscape, our motivational system's hardwired in there. But System 1, the difference between System 1 and System 2, the best way to think about it is actually a set of statistics which I find fascinating, which is every second we process 11 million bits of information unconsciously in System 1. At the same time, System 2, which is our conscious brain, the thing which for all of us, when we think about thinking, it's the conscious brain. But this is what gives it, puts it into context. Our System 2, our conscious brain, only processes 50 bits. 50 bits versus 11 million. If that gives you a sense of the power which most people aren't tapping into because they are so enamored with our consciousness. So there's this arrogance and bias towards, our conscious brains has led a lot of people not to actually understand how to actually work with both systems. So what Danny Kahneman sort of mapped out was this sort of concept of, hey, understand that System 1 and System 2 are working together. Unfortunately, there isn't a great language between it. Well, there is a framework which I developed, which is questions, which is a long story, which I won't go into, but basically questions are the best way to think about how to actually get your unconscious to be able to solve problems for you. Because this is a supercomputer which you have access to, which has been processing, by a huge margin, the largest percentage of information which have been inputted into your brain. So go back to the input process output. you're inputting so much piece of information that you're not even aware of most of the time. And it's coming in and learning. The system one is learning the patterns behind it. And if you know how to access it, this is what creates the aha moment. So everybody talks about this idea when you're trying to solve a problem and you're sitting in front of your computer and you've been thinking about it, you can't solve it, you walk away and you're doing something else, and suddenly the answer comes to you. You weren't thinking about it, consciously, system two, but suddenly the answer comes to you. So this gives you this indication that there's another part of your brain which has been thinking about this without making you conscious. It doesn't feel like anything most of the time, but it's been looking for those problems. And this is why giving it a question is what I call the programming interface for system two. System one. The system one, system two programming interface allows you to do this. So this idea of thinking in systems, like you said, I had a sense that I had a good framework and I spend a lot of time like testing and kicking the tires and making sure, but I wanted to use this metaphor, which there was a number of different researchers who I was talking to at the time who were thinking about, is a large language model really system one? It's not really system two yet. It's not, so the idea of people like using system one, system two language together with this new wave of AI, there was a lot of talk going on. And I realized that actually we're thinking about it the wrong way. Let's actually build out the full library of systems that we think with. And let's start with system one, system two.
So we start with system one and system two, our brains, and then you made a jump outside of the brain and you coined this term of system zero, building on, again, standing on another giant's shoulders, and those giant shoulders being Andy Clark. So what is this concept of thinking outside the brain? It's a new idea that you came up with. So help us understand. I think we're starting to get there, but how did you come up with this system zero? What is system zero and the extended mind? And how have we been thinking outside of our brains?
Look, I've been obsessed with Andy Clark for probably close to 20 years. And I did TEDx, which basically was this framework I came up with, which is called Mind 4.0 about 15 years ago. And what it really did was took this idea of Andy Clark's. And Andy Clark has this concept called extended mind. And what that really means is he basically explains that we're the only creature to be able to think outside our heads. So remember the thinking process, input, process, output. We can actually think with something outside ourselves, which most other creatures, from far as we know, can't do. And what Andy Clark has this great example to be able to visualize this of like, hey, you're playing Tetris. You're playing Tetris with a video controller, and he goes, when you look at Tetris and you see the block coming down, you can revolve it around to see how it fits. Sometimes you can do it in your head. Like some people just look at it, they can spin it and goes, oh, it fits into there. So you mentally simulate it and then you move the piece in. Some people, when playing the game, actually spin the piece using the controller to be able to make it easier so they can imagine it. So they didn't have to use as much imagination, don't have to use as much of our system two, our working memory, which is this limited sort of whiteboard space. And what he said was, what if, as you imagined it, you were actually connected to moving it? So get rid of the controller and make it as I think, it spins. So what he realized was that's the perfect example of what a true extended mind could be, when you can actually think outside your head. He also took it to the idea, like, whether it's cave painting, whether it's whiteboards, whether it's blackboards. I always loved from my research this idea of mathematicians are some of the heaviest users of blackboards, to the point they have blackboards in their elevators. These are like, even for, this building with about 3 floors, there's actually a blackboard in the elevator. This is how important it is, because the complexity of thinking that mathematicians do, they have to take things outside their head. And here's the other piece of system two. We've already realized that it's a difference between 50 bits and 11 million. Here's the other bit, which is really constraining. Your working memory size, which is your conscious brain, it's like a little whiteboard in your brain, and it can only fit so many things. And this idea of 50 bits every second, but a better analogy is this idea of you can only process about 4 items. It used to be the magic number 7. What it's actually come down to is about 4 items. So you can only fit on your tiny little whiteboard these 4 items. But if you can extend it, which is what humans can do, we can think about far more complex things. And this is what mathematicians done. So I took that and I built that into this idea of like, hang on a minute, not only do we have system 1, system 2, let's think of this external passive system, which we can interact with, as a system 0.
So you went down to system 0 and then to system 3. And now we get to the title of the Centaurian Christmas lectures, Thinking with Machines. And here again, we've got Gary Kasparov. So help us understand this system 3.
So this goes back to this famous competition which Gary Kasparov co-founded. So it's like this idea: anybody could show up with a computer, AI computer, and be able to play chess in this competition. And what people started colloquially calling it was centaur chess. And what it was is, the idea of a centaur is, human body and sort of a horse's the horse's body and a human sort of a head concept. So this concept of centaur and centaurians is what I started calling this idea of thinking with a machine. So taking Kasparov's idea, taking this idea of like, hey, what happens if you actually start thinking with a machine? So not only can you play chess, but what happens if you can actually do, more complex things? And that's what, whether it's programming, whether it's solving problems, whether it's innovation, all of these things, like the concept of if we can actually have the right interface, we can create a better system. So this idea of system 1, system 2, interacting with this external systems 3, which is intelligent in itself. So this is what I started calling Centaurian thinking. This was the nugget of the idea which started out, but then I started building all of these pieces together to be able to come up with this library of what I call 5 systems. So we've seen system 0, system 1, system 2, and system 3. There is another system which expands it even further.
And that brings us to thinking with the collective and this notion of collective intelligence. And because we can't talk about collective intelligence without acknowledging another giant on whose shoulders we're standing. And that's Abhishek Gupta, one of our dear friends who left us far too early and far too young this year. And yet you are able to take some of his thinking along with folks like Gianni Giacomelli at MIT, and extend it further. And here it is, this 5th thinking system that you have coined, and you're calling it System X.
Look, Abhishek Gupta, really close friend of both of ours. While working at BCG, he was at the Henderson Institute. I worked really closely with him. His research was around collective intelligence, and he exposed me to a lot of this thinking. And so this system, this idea of System X and how we can think with not only each other. So our collective intelligence is, the idea of Thomas Malone's superminds, we'll tap into the human collective, the hive mind, but also the fact that it isn't just humans, it's also other machines and other agents. So look, System X is dedicated to Abhishek Gupta. So Professor X, as I always thought of him, is this inspiration for System X. So this idea of System 1, System 2, your brain, interacting with the hive mind, this collective, this idea is called System X. So how do we extend it? How do we work with each other? How do we work with eventually AI, which becomes autonomous agents? We're starting to see with agentic workflows. So this idea of being able to use this whole library of 5 systems, 0, 1, 2, which are inside our heads, System 3, which is this concept of centaurs and centaurian thinking, and then tapping into the hive mind, the thing which has made humanity stand on the shoulders of geniuses over and over and over again. We're all standing on the shoulders of these giants who've gone before us. And System X, which is dedicated to the giant I'm standing on the shoulders of, which is Abhishek Gupta.
And this is phenomenal. And what better way to honor Abhishek Gupta than to name it, name for Professor X, System X. And so we've got these thinking systems. And then look, now we'll get to what so many people have been chasing after. And it's this notion of, all right, I hear that this is a disruptive technology. It's a transformative technology. It's one of the emerging, converging, exponential technologies bound to shift paradigms and create a new Carlotta Perez wave. I hear all that, but what are the use cases? So how are you thinking about use cases, Kez? And how is it different than some of the other folks who have been out there just banging the drum of prompt engineering and use cases?
Look, there are a lot of people who dove in like us, jumped into ChatGPT, Dolly and Midjourney and started using it. So there's this great Harvard Business Review article where these researchers had actually gone pulling from Reddit and other sort of social media sources and started collecting and cataloging all the different use cases. And they categorized them into these categories, which were the main use cases that most people were using generative AI. And this is this is close to like 6 months old, but still the majority of people, how people use it, this sort of taps into it. So this, whether it's research analysis, decision making, that's actually a very small percentage. Technical, this idea of assistance, troubleshooting, content creation. Creatives use this all the time. Creativity and recreation, learning, education, this idea of personal and professional support. I mean, whether it's a therapist, whether it's a coach, whether it's a mentor, these are the classic use cases that most people are using. But here's the thing, which as I started thinking more and more about, how do we think with machines? One of the core concepts I believe wasn't really tapped into was this idea of like, I don't think many people understand, when to use it, how to use it, and what are the circumstances to use it in different ways. And that's where my system model can come into play. But first, we need to understand a little bit about ourselves.
And what we can do when it comes to augmentation, naturally, you took it much, much further than simply saying, oh, let's augment. And this notion of an Iron Man suit for the mind, well, no accident that you went to a superhero, because what we've realized is that this new technology, these new technologies that we have created that are now proliferating, actually can give us superpowers. But with great power comes great responsibility and oftentimes some very crippling weaknesses. Many of us have heard some of the classic stories about how people have fallen prey to not really understanding what it is that AI is doing and going into a courtroom and presenting cases that have never happened. So what is it about superpowers versus kryptonite, and why did you choose this particular mental model and analogy to help people understand AI in a better, deeper, and more Centaurian way?
Look, one of the key things which I was trying to find the right analogy for was I realized that if you were very skilled at a task, like, for me, creativity, programming, research, like there's a number of different topics where I am off the charts. I'm really skilled in it. I've spent a lifetime doing a lot of these things. Like how you should use AI when this is your superpower already is very different than using AI when this is something you're not great at. So one of the things, and like you said, there's a lot of people out there who are using AI for the things that they don't like doing. They're not good at doing, they don't want to do, or don't think humans are. And this is, understanding, those areas which are your kryptonite. But this analogy goes a little bit further, because here's the underlying piece of that worst of times is there's a lot of people out there who don't understand what this idea of superpowers is. So if you think of somebody like Superman, generative AI is now going to give anybody, especially if you're willing to pay $20 a month to one of these providers, is going to give that power to anybody. And you can get to above average. So now everyone is going to have the same superpowers as Superman. But guess what? You're not on Earth anymore. You're actually back on Krypton, which is where we're heading. So when you're Superman with superpowers and everyone has it, that's Krypton. And what does it mean on Krypton? It means absolutely nothing, because everybody has the same superpowers. But this is where, the DC universe versus Marvel, what I loved about what Marvel did to bust Batman's and Superman's dominance of superheroes was they came up with so many different superheroes with superpowers, mutant powers. this is what we need to do. Because one of the things I love about mutant powers is they tap into something unique about us. So if you're trying to work out, what is your superpowers and being able to use AI in the right way to get a competitive advantage, you need to find that sort of true superpowers, which is beyond what everybody else has. So you want to lean into the things you're really skilled at. You want to get really skilled at more and more things. You want to learn more diverse things to become that unique superhero with superpowers, which is augmented by this AI, not just everyone's a Superman on Krypton.
So maybe you can help ground folks a little bit here on Earth and help us avoid thinking in systems and falling prey to the kryptonite.
Look, at some level, there's a lot of things which, you decide that this is something I don't want to become an expert at. I only need it for a certain amount of things. It's not my jam. And this is where you go to system 3 first, and then you think about it. It is important to do that last step to make sure you don't fall prey. You don't end up in court presenting cases which never existed. But this idea, look, law is not my thing, especially contract law. And I have to do this and look at contracts every now and again. So using a GPT to just have a quick look at this, give me all the things I have to look at, it gives me enough, makes me smart enough that I can ask the right questions and bring a lawyer in as needed. These are the people with the superpowers. Look, so use system 3 first, and then make sure you're bringing that rational thinking. Look, theoretically, this could be a topic. Eventually, if you start using it more and more, you might go, hey, I probably need to understand more about this. I should go and learn about it. But this is how, if something's a kryptonite for you, that you're okay if you're average or the same as everybody else. Look, there's going to be a lot of skills, a lot of things out there, which is going to get the level playing field. And just understand that it's okay to go to system 3, but make sure you're really thinking about system 1, system 2.
Right. And one of the keys here is that intellectual humility and that honesty with yourself. When you look at the underlying bell curve, if you know in your heart, in your mind, that you're below average in something, this is where system 3 can really benefit you, as you just talked through. And then when you are, as you said, off the charts and you are on the right side of that bell curve, and on the right side, not to say it's the correct side, but on the right side when you're looking at the standard distribution, this is where AI can really give you superpowers.
And look, when you take that unique skill, that thing which you can do, which nobody else can do, this is how to use AI. So first of all, there's a lot of people out there who go, hey, look, I'm really good at this. I'm not going to use AI. Or they use it in a very simplistic fashion and go, hey, this can't help me. Look, I did a lot of research on neuroscience, understanding how motivational system works, and built out this whole framework around game design. But guess what? When I tried to use AI at the start to help me synthesize that information, it actually, dumbed it down and took the average, which is out there. We'll get to this in a second, but basically, like, it did not understand my deep knowledge. So we had to really work with it to be able to get it to be able to do things. But guess what? It pushed me to go, hang on a minute. I don't need AI to give me answers in this scenario because I'm really skilled. I'm really knowledgeable. So this is where I spend most of the time in system 1 and system 2, incubating, ideating, pulling knowledge up, thinking about something, and then using AI, system 3, and potentially refining it afterwards. So this is where, this is a superpower of yours. This is this unique mutant ability that you have, or something you've trained, hyper trained over, decades of your life to do. You want to be system 1, system 2 first before you go to a system 3.
Think first, prompt later when it's a superpower. And speaking of those superpowers in kryptonite, well, much like our brains, LLMs have certain superpowers in kryptonite. And I love that you put this concept in this slide in this section and not in the section about what is AI, because when it comes to understanding how to think with machines, as you said, it's the human and the machine. It's the symbiosis. It's understanding what your superpowers in kryptonite are. And here you've got a chance to help folks understand a little bit more about what the large language model superpowers in kryptonite look like and are.
Look, this is a great sort of visualization. Stephen Wolfram wrote this amazing little book explaining it. He wrote a paper on it, and he had these amazing visualizations. And this is one of his, which is this idea of what's happening underneath. What is the mental model that the LLM has, right? So this is a model of something called semantic space. So all of these things are connected, similar to an associative network, and different topics are sort of clustered in different areas. So a large language model, which has been trained on all this corpus of information from the internet, creates this large sort of semantic web of information. So when you ask it something, you prompt it, it goes to a particular part of that network to pull out, the next word, eventually sort of building up sentence and building up knowledge from it. A great example of this is an early prompt hack, which people were talking about, was when you wanted to do something, go, hey, play the role of a contract lawyer and review this contract. What is it actually doing? It just goes, like, by saying play a role. It isn't like it knows how to play a role or knows exactly what a contract lawyer is. It just finds and navigates that part of this complex semantic web and be able to pull all that information out of it. Here's the other piece which you have to understand. This is a multi-dimensional semantic space. This is really complex, large language models. But guess what? You also have something similar in your own brains. But this mental model allows you to start thinking about this in a very particular way.
And as you said, it is multidimensional. We can't yet represent, the fourth or fifth dimension on a PowerPoint slide, but at least we've got 3 dimensions. So here it seems like you're blending some of these superpowers and kryptonite. So help us understand this view and this visualization, this way of looking at the elephant.
Look, one of the key things as I think about it's kryptonite. So when you've got a large language model, you have to understand what it's been trained on. So the sort of the rudimentary sort of idea, the rubric I ask people to think about is like, if you could Google this and found a video or a great blog post or a listicle or something about 5 years ago, there's a good chance that this is already in here. So when you're asking an LLM to do something, you're on pretty good ground if you're asking it something which you probably could have bubbled up and searched and Googled and found some YouTube on it. But if you're asking it something which has never really, had exposure to, it'll probably hallucinate. It probably is going to be fairly shallow. And, it's hard to actually be able to, find out what it's actually pulling from most of the time. These sources, it's not aware of its sources. So, that understand the kryptonite. There's this great example with ChatGPT Pro, which dropped, which is this amazingly powerful new sort of OpenAI sort of model. It's far more expensive, $200 a month. But here's where the piece which got really fascinating. So not only was there a whole bunch of people running around basically going, hey, it only works for PhD level problems. Yeah, it's really good. You don't need it. That's not true. It's actually for anybody who has superpowers in a particular area, you should be using Pro because it is amazing. But there was this great example, and there was a lot of people going, ha ha, see, it's not very smart. Somebody put a musical score into a picture of a musical score into Pro and asked it questions, and it hallucinated, claiming that it was something which it wasn't. And he was going, see, Pro isn't very smart. But here's the thing. Just because you can put a crossword puzzle in there, it can put programming in there, you can put mathematics in there, take photos, you can put a general ledger in there and it can work it out. It's been trained on all of those different things. It's very unlikely, and it hasn't been trained on musical scores yet. It wasn't something which is a high priority for OpenAI or any of these other technologies. So testing it on something it has never done, it's like testing me on musical scores. Look, I started playing music and reading music when I was 12 years old. I'm not the person to be able to recognize it. So it is not my jam. It is definitely not my superpower. So understanding the strengths and weaknesses, this is where you have to think about a large language model and understand where the superpowers and kryptonites are.